Weird ice that could form on alien planets observed for the first time. Previously predicted by theoretical models, we now have the first experimental observation of plastic ice 7. That might sound like a low-budget franchise movie, but it's actually an exotic phase of water that scientists think could form in oceans on alien planets. How exotic are we talking? Well, plastic ice 7 needs incredibly high temperatures and pressures to form. As temperatures and pressures rise, water molecules are forced into a variety of configurations and dynamics. An international team of researchers created ice 7 by squeezing water up to pressures of 6 gigapascal and heating it to temperatures as high as 327 degrees Celsius, which is 620 Fahrenheit, using high caliber instruments at the Institut Laue-Langevin, ILL in France, to watch closely as it changed phase. Ice 7 features a distinctively interwoven cubic structure, one where the hydrogen gets a little messy. Just what happens to the structure when it's permitted to melt, however, has never been clear, with some suggesting that molecules remain in place while their hydrogens roam around. The subtle nature of the hypothesized phase of water requires careful measurements of its hydrogen's movements rather than a snapshot of its shape, so it's little wonder scientists had not been able to prove its existence until now. One of the techniques used to identify ice 7 was quasi-elastic neutron scattering, QENS for short, when tiny particle movements inside substances can be traced by neutrons. The ability of QENS to probe both the translational and rotational dynamics as a unique advantage for the exploration of such exotic phase transitions compared to other spectroscopic techniques, says physicist Maria Rescigo from Sapienza University, Rome, Italy. And as predicted some 17 years ago, the research team was able to see hydrogen swiveling about at the microscopic level when ice 7, one of the dozens of ice phases we know about, is heated up and put under more pressure. However, there was one surprise: the molecules inside plastic ice 7 were not rotating freely, but turning in staggered steps. This is likely down to the way hydrogen bonds between the molecules are being broken and restored, the researcher says. The QENS measurements suggested a different molecule rotation mechanism for plastic ice 7 than the free rotor behavior initially expected, explains Resigno. The ice worlds far out in the universe, icy worlds such as Neptune or Jupiter's moon Europa, might have harbored plastic ice 7 in the past, experts think. Being able to observe how the ice behaves in the lab also gives us a better understanding of what's happened in the past to these planets and their satellites. That's one potential area of future research. Another is to take a closer look at how the transition to plastic ice 7 happens, which could be continuous and gradual and more abrupt based on modeling. The continuous transition scenario is very intriguing, says physicist Vivier Bove of the Sapienza University of Rome. It hints that the plastic phase could be the precursor of the elusive superionic phase, another hybrid exotic phase of water, predicted at even higher temperatures and pressures, where hydrogen can diffuse freely through the oxygen crystalline structure. And the research was published in Nature magazine. This is by David Neal on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.